Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome to the 2022 Astro Awards. Now, this is where we look back and reflect on all the exciting things that happened throughout the year in spaceflight and space science. This year had quite literally some of the biggest and most exciting launches of my lifetime, and tons of incredible science missions that have helped inspire the masses. So, without further ado, may I present to you the 2022 Astro Awards. Now cue that joke intro music that I wrote in like 5 minutes by literally smashing the keyboard for some of the notes. Go. Each year we pick our favorite space moments and then we pretend to give away an Astro Award, but it's actually just a paperweight that I got on eBay and I like it too much to give it away to anybody. So maybe someday we'll actually make an Astro Award and give it away, but still not the year for that yet. But the Astro Awards is our chance as the general public to lift up and celebrate and thank those who dedicate their lives and their work to furthering our knowledge and our understanding of not only the world that we live on here, but who also help us discover our place amongst the stars. Now for these awards, we do some ranked choice voting amongst our patrons and YouTube members, and we also did a poll on Twitter for the top slots, so thank you to all of you who participated. But at the end of the day, I do consider your feedback, but I personally just choose the final order because, well, this is my YouTube channel after all. So I put some weight on scientific significance, but also, cultural impact, and frankly, just whatever made me happy. And just remember, this is purely meant to be something fun and celebratory first and foremost, so don't be too upset if the mission that you thought deserved to be on the top wasn't on the top or wherever it was supposed to be on the list. It's all just meant to be for fun. Now before we get started with the awards, here's some fun notes about spaceflight and some mission progress we saw in 2022. There were the most orbital launches in one year ever. Again, which was up from last year when we saw 146 orbital launch attempts with 134 successful attempts. But this year we saw 186 orbital rocket launch attempts with 178 successful missions, which is absolutely astonishing. Another fun note for the year, I guess I'll become a real everyday astronaut in the near future because I'm going to be flying around the moon with the Dear Moon crew. Yeah, I'm guessing you probably saw and heard that by now, but yeah, I was chosen as a crew member for Dear Moon, and I will be flying around the moon on Starship as soon as we are ready. That's still absolutely crazy to even say, but I can't wait to start training and bring you all along for the ride as best as I can. And speaking of that, on that note, if you want a preview of what training might look like, I did get to ride in a fighter jet with the Polaris Dawn crew in 2022, and that was absolutely incredible. So if you haven't watched that video yet, you really do need to watch it. I promise it's not just me riding in a fighter jet. There's a lot of little learning moments, and I just had a ton of fun. And it was so fun flying with Jared Isaacman and the rest of the Polaris Dawn crew. They are amazing. Next, before we get into honorable mentions, let's take a few moments and reflect and remember some great people, missions, and programs that we had to say goodbye to this last year. Starting with a few important people who made an impact in space history. And of course, although not as close to as tragic as losing a loved one, we did see the end of some missions and hardware, planned or not, that I thought would be worth sending off. It's sad to see some of these missions come to an end, but every one of them far exceeded their expectations and lifespans and produced some awesome science throughout their days. Except for, I guess, DART mission, which died the moment it impacted Dimorphos exactly as planned. So that one, I guess, didn't exceed its lifespan because that would have actually been bad. Okay, now before we give out our Astro Awards, we do have some honorable mentions. Now these are missions or some science updates, and they're really just kind of, more exactly that, updates or just progress to report on, so they're not really Astro Award worthy. This year was a huge year for spaceflight in China, and one of the biggest milestones was the completion of the Tiangong space station. Now last year we saw the successful launch and we saw that space station go online, and that won it an Astro Award. But just 18 months after its launch, it is already considered complete. So it's already docked with both the Wenqian module and the Mengqian module, and has already seen 4 crewed missions go up to it, and everything has been completely successful, which is impressive. In general, China had a huge year in spaceflight. China eked out 64 launches this year, but had 2 failures. It's still quite an impressive year of launches, both crewed and uncrewed. But SpaceX alone wrapped up the year with an unbelievable 61 orbital launches, all of which were completely successful. Not to mention, they had 100% success with their landing and recovery efforts of their Falcon 9 and Falcon Heavy. Only 3 boosters were actually expended in 2022, and every one of them was intentional for performance and/or end-of-life considerations. That number of successful launches and landings is astonishing, especially when you consider that SpaceX launched almost as much as the entire country of China, at least as far as many times. But about 2/3 of China's launches were small sat-class launches. So SpaceX launched substantially way more mass, and they truly dominated the launch industry in 2022. SpaceX also had another new milestone by producing more thrusts than they have ever produced at one time with their Starship B7 Super Heavy booster. For just a brief moment, they had 14 of their 33 Raptor engines firing for a static fire test. Now, assuming 14 of those Raptor 2 engines were above about 70% throttle, they would have produced even more thrust than SpaceX's own Falcon Heavy rocket. I honestly just can't wait for the 33 engine static fire and launch. That's just going to be incredible to see. In 2022, Boeing and the United States Space Force's top secret X-37B spaceplane successfully came back down to Earth after a whopping 908 days in orbit. This marks the longest time a spacecraft has been in space and returned, at least in one piece, and successfully. We don't know a lot about what it's really doing up there, frankly, but that sure is impressive. Perseverance rover continued to make great progress by traveling around Mars and collecting samples, and it finally even pooped one out. Yeah, it dropped its first cached sample for a future sample return mission, which is very exciting. And its buddy Ingenuity went on to fly 19 more times for a current total of 37 flights with a total distance of 7.58 kilometers. This means it flew 3.76 kilometers in 2022, with its longest flight being a whopping 704 meters. We saw a handful of new rockets make it to orbit this year. Well, I might hesitate to say new, since a handful of these are kind of just new configurations of rockets, or they're based on other rockets or missiles, but nevertheless, here's what new rockets made it to orbit. We saw ESA's solid propellant-based Vega C successfully reach orbit on July 13th. There were also 2 solid-based propellant rockets that came from China this last year, the Zhilong 3 and ZK-1. China also launched their new Long March 6A, which featured strap-on solid rocket boosters for the first time. Now, I guess it was kind of the year of solid rocket boosters. Well, I guess except for Russia, who flew their Angara 1.2 rocket for the first time successfully. And we had one more really exciting scientific observation that's worth mentioning. Astronomers managed to take direct images of the supermassive black hole at the center of our very own Milky Way galaxy. Using the Event Horizon Telescope collaboration that first imaged a black hole in 2019, the teams managed to capture images of Sagittarius A. Due to its small size and its ridiculous 27,000 light-year distance from Earth, the teams managed to do what would be equivalent of taking a picture of a donut on the moon. And lastly, for the first time, a wholly commercially operated crewed mission flew to the International Space Station on a SpaceX Crew Dragon capsule for a mission called Axiom 1. All 4 crew members weren't part of, say, NASA, Roscosmos, or even on the payroll at SpaceX or anything like that. So similar to Inspiration 4 in 2021, but this mission docked with the ISS, marking an exciting collaboration with NASA and commercial partners. Now, this is kind of similar to what Space Adventures has been doing for decades now by sending people up to the ISS on Soyuz, including Yusaku Maezawa just in 2021. But it should be noted that there has always been a professional cosmonaut. But then again, Axiom 1 still had a professional astronaut on board. It was Michael Lopez Alegria, a 4-time astronaut, but he was, by all considerations, a private citizen on this flight, not an employee of, NASA or Roscosmos or something. The mission was planned to last 10 days in space, 8 of them on the ISS, but due to bad weather at the intended splashdown sites, the mission wound up lasting 15 days on the ISS and 17 days in space altogether. So the crew certainly got their money's worth. Now again, I don't think this mission is honestly anything that groundbreaking per se, but it certainly marks another milestone in what the future of human spaceflight will look like, where commercial operations are doing what only government organizations could have done prior. All right, I think it's time we move on to giving out some much coveted Astro Awards. So let's start off with a picture-perfect redo of a very important mission. There are 2 providers who have been hired by NASA to get crew to and from the International Space Station as part of the Commercial Crew Program. Boeing with their Starliner spacecraft and SpaceX with their Crew Dragon spacecraft. Both providers did an uncrewed test flight of their vehicle in 2019, but Boeing's Orbital Flight Test, or OFT, didn't quite go as planned. The vehicle had a handful of problems, and it didn't manage to rendezvous and dock with the ISS. However, it did re-enter and was successfully recovered. So fast forward to May 19th, 2022, and we finally saw a Starliner take to the skies again for OFT-2 on top of an Atlas V N22 rocket from Slick 41 at Cape Canaveral Space Force Station in Florida. After 5 days attached to the station, Starliner undocked on May 25th and headed back to Earth. After a deorbit burn, Starliner ditched its service module and began re-entry. After a successful parachute deployment sequence, the vehicle softly touched down at the White Sands Space Harbor in New Mexico, exactly as planned, ending a very successful test flight. This brings Boeing and NASA one step closer to putting humans on Starliner for their crew flight test, hopefully in the first half of 2023. So congrats to the teams at NASA, Boeing, and ULA for a great test flight of another one of the United States' crewed spacecraft. It's an exciting time to be alive with so many crew-rated spacecraft in operation at one time. Speaking of successful second attempts, Firefly Aerospace joined the Orbital Rocket Club this year with a beautiful launch of their Alpha rocket. After 3 launch scrubs due to weather and a helium valve, on October 1st, right at midnight, the 30-meter-tall all-carbon fiber rocket leapt off launch pad Slick 2 at Vandenberg Space Force Base in California, carrying about 35 kilograms worth of satellites. The rocket flew pretty retrograde, or against the Earth's rotation, at 137-degree inclination. This was done to maximize safety margins and minimize risk of an experimental rocket going off course anywhere near humans or property. Now, the rocket did wind up a little bit short of its planned 300 by 300 kilometer orbit and ended up at a 210 by 270 kilometer orbit, but it was still considered a hugely successful first orbital launch, testing out all of the major portions of flight, including an upper stage relight of their Lightning engine, which is very impressive. Firefly joined a short list of privately funded clean slate rockets to make it to orbit, being preceded by Rocket Lab's Electron, Virgin Orbit's Launcher 1. There's also Astra's Rocket 3, SpaceX's Falcon 1. But remember, Orbital Sciences Corporation, now owned by Northrop Grumman, actually made it to orbit with their privately funded and developed Pegasus rocket in 1990. But yeah, anyway. Alpha became the first rocket to use the tap-off combustion cycle to propel a rocket into orbit. I just absolutely love this engine. Now, if you don't know what the tap-off cycle is, may I suggest watching my video about how you power a rocket engine. It goes through all of the different types of engine cycles. Alpha is also the largest all-carbon composite liquid-fueled rocket to fly. At around twice as big and about 4 times as capable as Rocket Lab's Electron, it's a pretty big launch vehicle. But as for why do they deserve an Astro Award? Well, they knocked it out of the park and they did a couple of firsts, like the tap-off cycle. And I guess maybe I'm just biased because, you might know that I hosted their live stream. I was part of that production and was there behind the scenes, and I just absolutely love that company. And it was really fun to get up close and personal with a rocket right before it launched. I mean, I even touched it. It was just awesome, and talking to the team was super fun. So again, yes, I'm biased, and this is my show. So huge congratulations to the teams at Firefly. There's a lot of exciting things happening and a ton of momentum behind that company. So I can't wait to see what they do in 2023. South Korea officially became the 7th nation to get a spacecraft to the moon this year for a mission called the Korea Pathfinder Lunar Orbiter, or KPLO, also just called Danuri. The 678 kilogram spacecraft launched on a Falcon 9 rocket on August 4th from Slick 40 at Cape Canaveral Space Force Station in Florida. The rocket sent the spacecraft out to the Sun-Earth L1 Lagrange point, and then the spacecraft had to do 5 burns to get captured into lunar orbit. This mission is pretty exciting for a few reasons. First, that mission profile is pretty advanced, and it requires excellent mission planning and control to pull off such an intricate profile. It's also exciting because this orbiter is the first of the Korean lunar exploration program. Some of its primary objectives are to scout for landing sites for an upcoming lunar lander, take measurements using 6 instruments, including searching for resources on the moon, looking for ice in the shadowy regions of the moon, and also testing space internet technologies. So congrats to the Korea Aerospace Research Institute and SpaceX for a wonderful mission. Hopefully everything continues to go well, and we see them continue to work on their upcoming lunar lander. Speaking of lunar missions, Capstone was another exciting mission to the moon. The Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment, or Capstone, launched on an Electron rocket on June 28, 2022 from LC-1B in Mahia, New Zealand. It's incredible that Rocket Lab's tiny little Electron rocket is capable of getting something to the moon, even if it is only a 25 kilogram small satellite the size of a microwave. But I guess in a way that's also why it's impressive. A spacecraft the size of a microwave is capable of navigating into lunar orbit. And not just any lunar orbit, but it officially became the first vehicle to ever get into near rectilinear halo orbit, or NRHO, which is the hallmark orbit at the heart of NASA's Artemis program. Rocket Lab used an upgraded Electron upper stage called the Lunar Photon in order to get Capstone on a ballistic lunar transfer, which is different than a typical Hohmann transfer that we've seen be used since basically the early days of spaceflight. It took 8 burns of the Hypercurie engine on the Lunar Photon to get the spacecraft out on the ballistic lunar transfer. From there on, the spacecraft had to navigate to NRHO around the moon. After a trajectory correction on September 8th, there was an issue with a valve that caused the spacecraft to spin out of control beyond the reaction wheel's capabilities. But fortunately, on October 7th, a recovery command was successfully executed, returning control of the tumbling spacecraft. It left safe mode on October 27th, and it successfully entered NRHO on November 14th, 2022, in a 1,600 kilometer by about 70,000 kilometer orbit that takes about 1 week to complete. Capstone is proving out the low station-keeping nature of NRHO required to stay in a stable orbit, and is proving out the viability of the orbit for future crewed Artemis missions, including Lunar Gateway and upcoming lunar landings. So huge congrats to the teams at Advanced Space, Terran Orbital, Rocket Lab, and NASA for an outstanding mission, and doing it at a cost and scale that's mighty impressive. Speaking of demonstrating stuff for exciting upcoming missions, one mission in particular proved out an exciting technology: the Low Earth Orbit Flight Test of an Inflatable Decelerator, or LOFTED. LOFTED launched on an Atlas V 401 from Slick 3E in Vandenberg Space Force Base on November 10th, hitching a ride with the JPSS-2 weather satellite launched for NOAA. After JPSS-2 was deployed, the Centaur upper stage put itself and LOFTED on a re-entry trajectory. Before being deployed by Centaur, LOFTED inflated its giant heat shield from its pre-launch configuration of about 1.3 meters wide to 6 meters wide, featuring 7 concentric inflatable rings made of braided synthetic fibers, which is about 15 times stronger than steel. After decelerating safely through the atmosphere and at a very low temperature, the vehicle ejected a data recorder to make sure the valuable re-entry data survived even if the vehicle didn't or if it couldn't be recovered. About 2 hours after launch, Lovlyn pulled a parachute and safely splashed down, and it was fully recovered in pristine condition. The large surface area of the inflated heat shield massively increases the drag of the vehicle, which can help recover even larger items from orbit, while being lighter and potentially safer than a traditional heat shield. But even more importantly, this technology is very effective for Mars missions, where Mars's thin atmosphere doesn't aid in decelerating a vehicle nearly as much as Earth's atmosphere. Now, if you've ever played Kerbal Space Program, perhaps you know how awesome and effective these inflatable heat shields are. They've been something that the aerospace industry has wanted to see developed, so to finally see one demonstrated at orbital speeds is awesome. But we should also see this technology on a rocket soon. ULA, who was a partner in this mission and launched it, has a keen interest in inflatable heat shields, as they hope to use one to recover the BE-4 engines on their upcoming versions of their new Vulcan rocket. So congratulations to the teams at NASA and ULA for a picture-perfect mission that has an exciting technology that could help make both reusability and Mars missions even better than before. This next one was a smashing success. It's easily one of the most impactful missions of the year. NASA absolutely crushed it with this one. Yeah, if you can't tell by my terrible puns, I'm of course talking about the Double Asteroid Redirection Test, or DART. DART was actually launched at the end of 2021, as we mentioned in last year's honorable mentions, on top of SpaceX's Falcon 9 on November 24th from Slick 4E in Vandenberg Space Force Base. For about 9 months, the DART spacecraft and its little companion CubeSat named the Lycia Cube navigated towards a pair of asteroids named Didymos and Dimorphos. These are pretty small asteroids that orbit the Sun on an elliptical orbit from about Earth's orbit out to even beyond Mars's orbit. These two asteroids are pretty special because Dimorphos actually orbits Didymos, and it did so once every 11 hours and 55 minutes. Their orbital period can be very precisely measured from Earth because we can see when Dimorphos passes by Didymos, and scientists can measure its orbital period with extreme accuracy. Okay, so why is that special? Well, here's where the brilliance of the DART mission comes in. The whole point of the DART mission is to see if impacting an asteroid is an effective way to change its velocity and therefore its orbit. But the reason this is just so genius is because they can measure it so accurately. Since they can measure it down to the second, it's really easy to see any very minor change in velocity. As opposed to if they were to run into an asteroid that's just orbiting the Sun, it'd be a lot harder to detect such a minute change in its orbit. With asteroids often being loosely lumped together rocks, it wasn't known if running into one would actually move it much, or if it'd be more like shooting a snowball or something, where it just disintegrate into billions of pieces. 10 days before impact, DART deployed Lycia cubes so it could observe the impact from a safe distance and transmit data and images back to Earth after the impact. Knowing DART would obviously stop transmitting data the moment it smashed into Dimorphos. On September 26th, DART collided with Dimorphos at an incredible 6.6 kilometers per second, which is almost 10 times faster than a bullet fired from a sniper rifle. Yeah, so a 570 kilogram bullet and going about 10 times faster than a bullet. That just puts into perspective just the crazy amount of kinetic energy that a rocket can deliver. Lycia Cube wasn't the only thing imaging the impact. Oh no, we pointed almost everything we had at the impact. So James Webb Space Telescope, the Hubble Space Telescope, and even some ground-based observatories like the Magdalena Ridge Observatory. So how'd it turn out? Based on the estimated mass of Dimorphos and the potential kinetic energy of the impact, NASA was hoping the orbit would be shorter by about 73 seconds, which was their minimum change in orbital period to be considered a successful demonstration. But instead of changing it by 73 seconds, they changed Dimorphos' orbit around Didymos by a whopping 32 minutes, which is about 25 times more than they were hoping for. This is monumental. The asteroid didn't simply disintegrate, it took the impact square on, and boy, did it change its velocity. This is absolutely vital for our understanding of potentially moving an asteroid that's on a collision course with our own planet. Now, given enough time and assuming we have even more lift capabilities like Starship or SLS, we might stand a chance to prevent an extinction-level impact someday. So huge congratulations to the teams at SpaceX for the perfect launch, the Italian Space Agency for LysiaCube, Johns Hopkins Applied Physics Laboratory, and NASA for not only helping to keep us safe someday with perhaps the most important mission to date, maybe, but for finally avenging the dinosaurs. Ever since I started visiting Kennedy Space Center as an adult in 2014, the rocket that I've been waiting to see fly in just a few years finally took to the skies, and boy oh boy, was it spectacular. After over a decade and some big delays and budgets, NASA launched their most powerful rocket ever, the Space Launch System, otherwise known as SLS for Artemis 1. Now, I probably don't need to even explain this one to you very much, considering it was easily one of the most anticipated and literally the biggest launch of my lifetime. But here's a quick little overview. On November 16th at 1:47 a.m. Eastern Time, SLS took off from Launch Complex 39B at Kennedy Space Center, carrying an uncrewed Orion capsule on top. Destination, distant retrograde orbit around the moon. Artemis 1 certified both the Orion spacecraft and SLS Block 1 for crewed spaceflight, which is vital considering its next mission, Artemis 2, will be crewed. It will take a yet-to-be-announced crew to lunar orbit for the first time since 1972. This orbit marked the furthest a spacecraft certified for crew has been from Earth and back at over 450,000 kilometers away from Earth. Additionally, this mission marked the longest a spacecraft has ever free-flown, so not docked to anything else, with a mission duration of 25 days, 10 hours, and 53 minutes. At the time of launch, the SLS Block 1 rocket became the most powerful operational rocket in the world, surpassing the previous most powerful rocket in operation, which was SpaceX's Falcon Heavy, although it may soon be beat out by SpaceX's Starship rocket. But SLS did manage to beat its predecessor, the Saturn V, in terms of sheer thrust at liftoff, although it doesn't quite beat the Saturn V in terms of payload capability. In addition to the Orion spacecraft, SLS launched 10 6U smallsats as part of a low-cost CubeSat mission, which were mounted on the stage adapter. By all accounts, this mission went phenomenally well. The SLS center core with its 4 RS-25 engines performed perfectly, along with the 2 solid rocket boosters which performed extremely well. The interim cryogenic propulsion stage, or ICPS, also performed perfectly, which is no surprise considering it's just a modified Delta cryogenic second stage from the extremely reliable Delta IV Heavy. The Orion spacecraft and its European service module also performed exceptionally well, doing a handful of precise maneuvers, going from only 128 kilometers from the surface of the moon, getting into and out of the distant retrograde orbit, and then precisely maneuvering back to Earth. The biggest and most important test of the whole system was actually testing out the heat shield on the Orion spacecraft at the extreme velocities experienced when coming back from the moon. Re-entry, parachute deployment, and recovery all went perfectly. But why does it matter? Why is this worthy of one of our top spots? An uncrewed rocket made up of literal leftover parts of the space shuttle? In a way, this rocket is a relic of spaceflight past. Why is it worth celebrating, considering how late and over budget it was? Well, it's now been over 50 years since humans have been to the moon. That's insanely depressing to me. Today, we have so much better technology, experience, and know-how than we did during the Apollo program. But every program trying to return to the moon since has been canceled. But we finally have a program that has now survived 3 administration changes, 3 NASA administrators, and most importantly, huge changes at the congressional level. And that right there is something to celebrate. But that on its own is not worth celebrating at all. NASA had to deliver. Actually, NASA had to do more than deliver. They had to hit a home run. If Artemis 1 had failed, it truly would have pumped the brakes on this entire program and put it all at risk of another devastating cancellation. And don't forget, there's a lot more than SLS and Orion riding on the success of the Artemis program. Because after all, NASA chose SpaceX's Starship as the lunar lander, and they've already paid them over $1 billion to land humans on the moon for Artemis 3. And they're already procuring more lunar landers and a brand new EVA spacesuit to walk on the moon in proper 21st century fashion. All of this progress and momentum is literally riding on the success of SLS and Orion. And we finally have a vehicle capable of getting humans back to the moon. Not only capable, but certified now. And that is absolutely worth celebrating. Finally, we're actually making progress to seeing humans land on the moon again for the first time in my lifetime. I can't wait for that. And in the meantime, we need to give a huge shout out to the unbelievable images we got back from this mission. I am so happy that NASA included so many cameras on Orion for the sole purpose of inspiring us humans back on Earth. Because the images and videos from this mission were astonishing. I saw these shared everywhere, and that really matters a lot. So huge congratulations to NASA, Boeing, Lockheed Martin, Northrop Grumman, ULA, ESA, and Thales Aerospace for a picture-perfect mission and ushering in the exciting Artemis era. Okay, my friends, last but obviously literally not least, we have one of the most incredible missions and the start of one of the most important programs ever. The James Webb Space Telescope, or JWST. As you maybe know, last year we kind of gave JWST an Astro Award prematurely. Well, we actually gave the launch of JWST its own Astro Award, and I mentioned at the time that it was highly unusual because, the mission hadn't started. JWST hadn't really done anything at the time. It really just sat there and rode on a rocket. But it was worth celebrating the fact that the launch itself went flawlessly. The Ariane 5 delivered JWST so precisely that it likely extended its expected lifespan to about double what NASA was expecting. And everything was healthy after billions of dollars and decades in the making. But the scariest, most complicated, and maybe the most ridiculous deployment sequence had yet to be done, which is why the launch was at the bottom of last year's list. But this year, we get to celebrate James Webb Space Telescope officially going online and making incredible images. James Webb began its intricate, delicate, and daring unfolding process. With 344 single-point failures, any one of those could have spelled disaster for the most expensive satellite ever. On January 24th, JWST officially arrived at the Sun-Earth Lagrange Point 2 with a perfect and precise insertion burn. But then we waited. Yeah, we waited. The telescope was now in the right place and orientation to begin to cool down to minus 233 degrees Celsius, which is actually cold enough for oxygen to condense down into a liquid. But that extreme cold temperature is also necessary for the sensitive infrared sensors to work properly. Then each and every one of the 18 mirrors was carefully calibrated to the precision of 1/10,000th the size of a human hair by a set of really precise motors. I almost think those motors alone are worthy of an Astro Award. After a handful of initial instrumentation and calibration images were released to update us with the progress, we were finally shown the first full resolution images on July 11th, and wow, was it worth the wait. JWST has already proven itself to be a massive leap in imaging the darkest parts of our universe. No instrument has ever been so sensitive and so capable of seeing dim objects before. It's so sensitive that it could collect the photons coming out of your phone's flashlight from Earth if you were standing on the moon. Or it could even see the heat signature of a bumblebee on the moon from Earth. That's ridiculous. And it's not just the sensitivity, but it's the overall engineering that is so amazing. If we expect to maybe see 1 photon per second from some of the furthest stars, only about 25% of those might actually be detected. So we can see a single blip of light from these stars once every 4 to 5 seconds. But to put this into perspective, is just the dust alone in our solar system, the dust puts out 5 times that many photons. It's just crazy. So who even knows what this technology and science behind filtering out that noise will do for future imaging, both terrestrial and in astronomy. And I can't even begin to state how big of an impact the images from JWST have had already. Social media has just gone absolutely crazy with all these beautiful new images. Okay, maybe I'm just a sucker for pretty pictures, but in reality, all this stuff does matter for public opinion and funding. This is a knockout mission, and it's certainly helped gain some public interest in science and astronomy and spaceflight. I can't even imagine what all we're going to discover with the power of JWST, but all I know is that we're quite literally just at the beginning of its incredible journey. So our biggest congratulations to the teams at NASA, ESA, Northrop Grumman, and Arianespace for getting the most important instrument that will help unlock our understanding of our universe like never before online. Okay, now in summary, we should say all 3 of these last Astro Awards are pretty much a 3-way tie for me. They're all extremely impressive and vital in their own ways. Some are maybe more important in some ways than others, but all of them are downright huge and really, really important missions. But it doesn't really matter because NASA was the recipient of all 3 top spots this year. 2022 was jam-packed full of monumental spaceflight and space science events. And maybe it's some good old American bias here, but wow. NASA had an amazing year. It's been really fun to watch some of these huge long-term investments finally pay off and work flawlessly. But there's still tons more in store. I have a feeling that 2023 might be even more exciting, at least in terms of launches, than 2022 was, especially with Starship and a ton of Falcon Heavy launches and lots of new companies trying to get rockets online. It's gonna be exciting. But then again, it's gonna be hard to beat the space science that was done in 2022. But regardless, I can't wait to see what all you brilliant people out there end up accomplishing this year. And that, my friends, is what the Astro Awards are all about. Cheering on those who make all of this possible. The engineers and scientists who inspire each and every one of us, who lose sleep over their projects, who dream big, and teach us about our very own universe. And with that, thank you to all of you who are watching this. To those of you who have subscribed here and been a part of this incredible community, for the encouragement, the patience, the love, and the support. It all really, really matters. And I just can't wait to continue this journey with you guys, especially with things like the Dear Moon Project and all the other exciting things in store. And honestly, all of this is only possible because of the generous financial support from both our Patreon members and our YouTube members as well. If you guys want to help me continue to do what I do, head on over to patreon.com/everydayastronaut or hit the join button to become a YouTube member, and you can get some fun perks like early access to some videos, script read-throughs, and just lots of other really fun little behind-the-scene things. And of course, while you're online, don't forget to check out our awesome merch store for shirts like this. This is actually a reissue of our limited edition gold Aerospike shirt. There's only a handful of them left in stock, so get it while you can. But also check out our new dresswear, our schematics collection, our future Martian collection, our Falcon 9 model rockets, and lots of other fun stuff at everydayastronaut.com/shop. Thanks everybody, that's gonna do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.